Welcome to Unite Now, where we bring unity to you, wherever you are.
Hello everyone, and welcome to Unite Now. In this presentation, I'm going to talk about how to improve your animation workflow with animation rigging. My name is Ciro Continisio, and I'm the lead evangelist for the EMEA region at Unity. In today's agenda, we have a few things. As a first step, we're going to take a look at the animation workflow itself. We're going to establish some terminology so that we understand each other during the course of this talk. Then we're going to dive into the features that the animation rigging package provides, and focusing on two different aspects. Runtime rigging, which is a feature that enables the creation of procedural animation at runtime, and animation authoring, which is a workflow that allows you to create animation from within Unity, and we made that even more powerful in 2020.1. Here and there, I'm going to jump into some in-editor demonstrations, of course. I don't just want to have you look at the slides all the time. And we're going to take a look at a small project which enables these two workflows in action. First things first, we want to talk about the animation workflow. The workflow is made up of different steps, and some of these steps happen outside of Unity in what we call DCC tools, digital content creation tools. This can be software like 3D Studio Max, Maya, Modo, Blender, Madbox. There's so many software that can help you create your 3D models. And then we have steps that happen inside Unity. So obviously, everything starts with modeling. This is where you define your mesh and you define the resolution that the mesh is going to have, which actually affects the animation quite a lot. In this case, you're seeing an image of Blender. Then you have a step called rigging. Rigging is where you establish the relationship between the mesh and the skeleton. So in this first part of rigging, you have the skeleton creation. You have the part where you want to define the bones, where they're placed, and which one is a parent of which bone. And then you have something called skin weighting. Skin weighting means that you give a weight to the skin which wraps around the bones. The skin in this case is obviously the polygons and their vertices, right? And to each vertex, you assign a weight, meaning that each bone in the skeleton you defined previously is going to affect that vertex more or less depending on their weight. Finally, once you've done all of this setup, you can animate. And animating means creating keyframes for the software to interpolate. So keyframes are basically key poses for each and every bone, and then the software finds what is called the in-betweens, basically the positions in between these two keyframes. In this screenshot, you can see again Blender, and you can see the animation panel at the bottom there. It looks very similar to the one in Unity actually, and you can see some keyframes on different parts of the mesh. Actually, of the skeleton. You can see that we're not animating the mesh, but we're animating the bones. Right upper arm, spine 1, left upper arm, and so forth. And then we get to the point of this talk, right? Like what you can do for animation in Unity. As you know, Unity has a very comprehensive animation tool, an animation panel, and then you can create animation in timeline as well. But our suggestion is not to create animation directly within Unity. We believe that there's a certain value in creating animation still in your DCC tool of choice. They have so many tools that are really great to create amazing animation. But what you can do in Unity is do what we call in-editor animation. And so you can create stuff like interactions with gameplay, so stuff that is only happening in Unity, and you adapt the animation to it. Or you can create some animation tweaks. So somebody has created the animation outside of Unity, you import it in, and then you tweak it to a specific situation that is happening in your game, maybe in one specific scene. So these two workflows are what we're going to talk about in the context of this talk. I chose a demo that we have on the Learn website, which comes from a few years ago. This is called Adventure Game, and it's a game that was made by our Learn content team. And, I chose it for a couple of reasons. The first one is that this game, as you can see, you could call it low poly these days. And it's a game that could probably run on a mobile perfectly. So it's not really a high-fidelity game. It's not a AAA production. And for this reason, I wanted to show you how this package, which we usually associate with AAA or AA quality characters, it can actually be used with low poly models, cartoony characters, and so forth. It's really useful for them as well. And then the second reason is that this demo is the perfect example of a project where you don't have access to the original animation files, the source files, because this has been made a while ago. The animators that worked on it, I don't have access to them. So you can think of this in realistic terms. For example, you have your game, you made it a couple of years ago, and now you want to launch it on a new platform, maybe on mobile. So you want to make a port, and you want to add some more content, some more scenes, some more animations, but you don't have access to the original contractors because maybe their contract finished a while ago. And so through this package, you can make these tweaks to obtain new animation out of old content. The number one feature enabled by the animation rigging package is runtime rigging. Runtime rigging is the process of modifying skeletal animations at runtime using constraints. Basically, we want to constrain the skeleton that we created before, and we modify the pre-existing animations while the game is running. Its main use cases are something like animation as gameplay feedback. Imagine a character has like an enemy or an interesting point, a point of interest around them, and you play an animation as feedback. So you make the head of the character turn in the direction of this point of interest. And that's a feedback for the player that something is going to happen or that they can interact with something. That animation doesn't exist before, but it's created at runtime. Similarly, you can modify animation in response to gameplay. So something happens in the game. Let's say, for example, the character is bumped into by another character, or they have to, the player presses a button and they want to reach out for an object. Then you can play a new animation, like for example, an IK-based animation where the arm reaches out for a point in space which you couldn't predict before because it's a result of gameplay. So these are the main use cases for runtime rigging. Before we go into more concrete use cases, I just want to show you how to set up animation rigging on a character. It's quite an easy process, but we made it even easier in 2020.1. The first thing you want to make sure of is that, of course, you have the package installed because animation rigging comes as a package, and you go to the package manager and you download it from there. Once you have it, you can select your character. So in my case, I have the character, which is a game object for now. And as you can see, it has an animator. Animator is a fundamental component to use animation rigging because the package uses it to drive animation, to override animation if you want. And so this one has it. It has a state machine already set up with a few animation clips. Then it has a skin mesh renderer, which displays the graphics, and then a bunch of bones under the skeleton. So if I expand the hierarchy, it looks like this. And they've been animated in the DCC tool. To set up animation rigging, I select the character, go here, and select Rig Setup. When I do that, a couple of things happen. The first thing is that Unity adds a component to the root object, which is called Rig Builder. The Rig Builder is the component that drives the constraint and overrides the animator values. Then I have a new game object here, created for me, which is called Rig1, and it has a component called Rig. Now, rig components are basically layers. They act as containers. I create my constraints under them. And with one or multiple rigs, I have the ability to fade in and out the constraints as a group. So now I have no constraints for now, but I'm going to create one very soon, and then I will be able to fade them as a group. The other important thing is that the rig object is connected here on the rig builder on the root, but with that option, Unity does it for you. Now, if I want to create a new constraint, I can go to here and I say, for example, I want to have a right arm IK constraint. So I want to constrain the right arm to behave in an inverse kinematic way. I create a game object. I go to Add Component, Animation Rigging, and I select 2-bone IK constraint. This is the one I want to use. And now I need to set up this one. Before I do this, I want to show you another little trick that we added in 2020.1. So if you go to the root object, let's say that I want to visualize the bones that are inside the character, because the bones are usually invisible objects, they're just empty game objects. So to do that, I have a new component called Bone Renderer, but in 2020.1, I can go to here, select this option, and as you can see, the Bone Renderer is already added and configured for me. So Unity adds the whole hierarchy of game objects under the Bone Renderer and adds it to it, adds the game objects to it. And so you can visualize and also pick the bones from the scene very, very easily for animation. The little trick that I want to show you as well is that you can actually have another bone renderer. So if I go back to the root of the object and I deselect this one, and for instance, let's say that I take the upper arm and I select the option again, you can see that now I have a new bone renderer set up on this object, and that it just automatically takes all the children of this arm bone. And you can assign it a different color, for instance. And this is super useful if you're only working with the arm and this is the only bones you want to see. The other thing you can do is you can actually drag this component directly onto the root, so it gets transferred to that object. And now you can have both the arm bone renderer and the full body bone renderer in the same place, and you can switch between them. So let's say that I leave the arm on because that's what I'm going to use. Let's now set up the IK constraint, which I left empty before. To do this, there's yet another option which we added, which makes it much easier. So the only thing to set it up is I need to, well, first I can open this inspector by selecting this option here, properties, in a new location. And now, for example, I can dock this inspector here. And this inspector is going to be locked onto this object. So even if I unselect the object or I select any other bone, here I see the thing that I have selected. And here I will always see the IK. So this is a new nice thing which we added in 2020.1. And now I can actually select the hand and drag it into the tip. And once I've done that, even though I only assign the tip, I can right-click on the component itself and choose Auto Setup from Tip Transform. I do that, and Unity automatically finds the three parts of the IK chain, and then it adds 1 and 2 objects here, which are going to be my controls for this IK. The first one is the target. This is the one that basically the IK will move towards. And another option you have in animation rigging is you can add locators. So, effectors. And you can have the locator one. I like the ball one for the target because it allows me to pick it up very easily, on top of other objects as well. And then what I can do here is I can select the hand, which I want to have the target at the same position, and I can right-click on its transform, copy word placement, and I go to the target, and I select, and I do paste word placement, and it moves here. I can actually close the inspector of the IK for now. And then I want to move the hint as well. And the hint is the object where the IK will bend towards. So this determines where the elbow will bend. And so I put it here at the back, and I choose just a regular locator effector. This is because I don't really care about the hint most of the time, so I don't want it to be in my face. But I can still pick it if I have a situation like this, and I can move it and keyframe it whenever I want. The target is here, so the IK is now ready to go. But you will notice if I move it, nothing happens. And that's because IK, like every constraint in animation rigging, has two phases. One is the setup phase, which we just went through together. And during the setup phase, the constraint is not active yet. And the setup phase happens in edit mode. So I'm in edit mode right now. You can see that I'm not in play mode. This means that I'm in setup. To see the constraint actually work, and every constraint that I might add later, I need to be in another mode, let's say. And there's three ways to see the constraint work. Number one is to press play. If I press play, I will see the constraint go into effect. Number two and number three are the preview modes of the animation and the timeline panel. So this little button here, preview, brings you into something which is called animation mode. And animation mode is a way to preview constraints. So for instance, let's take the animation panel. The character obviously has an animator which contains animation clips. So if I click this, I can see that it has a few states. Each state is assigned, actually not this one. Let's correct this one right now. It's player idle blender. So this state is now connected to an animation clip. And if I go to the animation panel, I can see the clips that the character has here in this dropdown. And as you can see, they're read-only because they're coming from an FBX, meaning that I cannot change them for now. But let's take a look at the idle blender. And as soon as I select it and I move this control, you can see that the IK is now in effect. You can see that the arm is being controlled by the target. And if I move the target, I can see that the arm reacts. And I can now position the target and create some animation. You will notice, though, that if I move the animation again, the thing snaps back. This is because I'm not recording yet. So always make sure of which mode you're in. You have preview, and then you have record mode, which is right now unavailable because this clip is read-only. So if you can't click this one, it's because the clip belongs to an FBX file, so it can't be modified yet. So again, preview mode allows you to see the effects of the setup. So first you set it up, you bring it to the position you want, and then you preview and you check if it works. And if you want to move it, you don't move it here because this will be reset. You just exit preview mode and you move it, right? And then if you enter preview mode, now you can make some changes. For example, right now I wouldn't Control Z, but I would exit preview mode and Control Z. And now I'm sure that when I enter preview mode, the constraint works fine. Exit preview mode, and I see the setup position again. So how do I actually record some keyframes if I wanted? Well, it's quite easy, and it's actually something that doesn't relate to animation rigging. It was the case before as well. The way you do it is you need to make sure that these clips are not read-only, and the way you do it is you want to basically find the clip. So you go to here, you can click on this one once, and the clip gets pinged into the project panel, and you can select it and hit Control D or Command D on Mac, and Unity creates a copy of the clip, which, as you can see, is outside of the FBX. And now we can rename it. Let's call it improved. And now we want to also assign this clip to the animator. So here in the state, we want to connect the improved clip. If I go back to my character and I open the dropdown, you will notice that the improved clip doesn't say read-only because it's not read-only, it's writable. And in fact, the record button is now enabled. So now, in addition to being able to preview the effect of the constraint, I can actually hit record and maybe go at the beginning, select my target, bring it down, and now I can start adding keyframes and decide like the initial position of the hand, and maybe at this point I want to bring the hand up, and you can see how the IK is now in effect and is also animated. And in fact, if I scroll down in the clip, I can see the two new properties that I just animated, which are here. And obviously I can modify them in the curves, and all of the nice tricks that Unity has in its animation workflow. But I just to recap, I keyframed a constraint in a pre-existing animation clip by duplicating it and making it editable inside Unity. And now, as I said before, always be mindful of which state, which mode you're in. So you want to exit record mode, and now you can see the preview of your animation. And if you want to exit preview mode, you can then tweak, for example, the setup of the constraint again. And when you want to preview again, you just scrub the animation file. You will notice, because this button is enabled, this bar is in blue. And if you select the, for example, the target, you see that the properties are in blue, because that means that these properties are being driven by the animation clip. Again, so 3 modes to see the constraints: enter play mode, preview, so animation mode in the animation panel, or animation mode in the timeline panel. We're going to take a look at the timeline later on. Now, to complete the setup that I needed for my use case, I had to add another couple of constraints in addition to the one that I've shown you. So if I select the character here, I actually have not only the right arm IK constraint that I set up before, but I also have a left arm IK and a twist chain constraint, which I'm going to explain in a second. As you can see, I've put them all under one rig so that I can use this rig as a sort of layer and fade them in and out whenever I want. The twist constraint is actually a very simple constraint which has 2 control objects, in this case these 2 circles that I've assigned a circle effector here. And what it does is that it takes a chain of bones and it interpolates the rotation of the first control and the rotation of the second control throughout the chain, so that I can just control the rotation of these 2 objects, and with that control the whole rotation of all the bones in between, in this case the spine of the character. So it simplifies the rotation of multiple objects in one go. And I use this one to make the character basically bend forward to reach for an object on the ground. You will notice obviously that if I select and I move these things, they don't show anything. As we said before, we want to be in play mode or in animation mode in the animation panel. So let's do that. Let's select the idle clip, and as you can see, she's animated. And now actually I should be able to see this, but what happens here is that you will notice if I select any of these constraints, you will notice that the weight of all of them is at 0. And the reason for this is that even though these constraints will be useful at some point in the game, I actually don't want them to be on all the time. Most of these animation clips are perfectly fine, so I don't want to, for example, this one is idle. I don't need any constraint here, so I don't want the constraints to be actually active. They only become active in some specific animation clips, which I have modified. And that's where I want to have my tweaks, basically. So in this case, for example, we can, just to visualize the twist, I can go anywhere in this animation, and if I bring the bone, the weight to 1, now I can visualize the twist and I can show you what's the effect of it. So as you can see, through these 2 controls, I can rotate them, and then the bones in between will interpolate to accommodate the rotation. But before, instead of using this clip here, let me show you the use case that I wanted to have with this character and with these animations. So the point is, this demo had an animation where the character reaches for an object on the ground and picks it up. And even though this is a great animation, the point is she's reaching for one specific point on the ground, while I wanted this point to be dynamic and I wanted to be able to move it around, or if the point is anywhere in the play space and she approaches that point from any direction and maybe different distances, the hand needs to be reaching to the object. And I can only do that through animation rigging and a rig that acts at runtime. So what I've done here is I've duplicated this animation clip. Here I have player take object low underscore improved. As you can see, it's not read-only. If I select it, I will see she goes for it and she reaches for it, and then the arm points upwards. This is a bit weird. I'll explain why now. But basically here, all the constraints are becoming active. And if I scroll down, you'll notice that here I have keyframed all of the constraints to become weight 1. So if I select them, actually, you will see that the weight is at 1 at this point in time, and then they go to weight 0 again. So I'm basically blending in and blending out all of the constraints to have a moment in the animation which is dynamic, and then go back to the original animation clip, which, is perfectly fine as it is. The reason why the arm is pointing up is because, as you can see, the target is still in the air, is not on the ground. And the reason is this target is going to be set up by a script at runtime. So I don't want to keyframe it, because if I do keyframe it, then the script is not gonna work, because this animation is actually overriding the script. So what you can do here is that while you're working on this animation clip, you can actually take the object, take the target, and put it in a sensible position where you're editing the animation, and actually make a few tests. So for example, here with the right arm IK target position. Let me remove this key here. I just want this key here at the center. I can make a test and see how it looks like this. And then I can extend the arm like this and see how the animation plays in this case. And so I can make a few tests and kind of like stress test the animation and see how it looks like. You see that there's extreme positions where the arm goes inside the leg. So I did my best to accommodate as many positions as possible. Once I'm done with the test, I basically remove the keyframe again. So I'm not animating this property anymore. And my animation clip is complete, basically. And now what I can do is I can go into play mode. And as I said before, I have a script that the character has, which is a very simple script. It's just a simplified version of a pickup script. I have a coin here on the ground. And as you can see here in the scene view, whenever, and I need to put this one side by side, whenever I press the C button, she will reach for the coin and grab it. So the idea is that wherever the coin is, so even if I put the coin on this side here and she does the same, you see that the target snaps by virtue of the script. It snaps to that point, and then the animation plays dynamically to accommodate that movement. So wherever the coin is, the coin can be here. So it can be like closer to her left foot. It could be a little bit higher up on the ground. Maybe there's an object that's the coin is resting on. And then when I press C, you can see that the animation is adapted to wherever the target object, so the coin in this case, is going to be. So if I put it here, look here, and she reaches for it. Obviously, it's a simple animation, like the coin disappears under her hand. But you get the point. Like with this situation, you can have a script that sets these objects dynamically in space, or rotates them, or whatever you prefer, and then the animation will be dynamically calculated at runtime to adapt to that situation. So it's a super powerful tool to create animations that are really dynamic and react to whatever is happening around the character. Again, building on top of animation that was already created before and tweaking it just a little bit. So now that we have the character fully set up, we can start having some real fun and use those animations that we created for the gameplay, for example, in a timeline as well. In this case, so I want to go to timeline, and if I select this object here and I enable it, you will see that the character is again here. It's actually exactly the same prefab that I used before in the gameplay, which you can see here. In this case, though, I've added an extra rig on top. So in addition to the twist chain that she has on the spine and the two IKs, I've also added a couple of extra constraints. An head constraint, a multi-head aim constraint, which is gonna turn the head towards a certain point in space, in this case, the coin that we wanna pick up, and a coin constraint, which allows me, multi-parent, which allows me to reparent a coin to her hand when she picks it up. So, and this is important to understand because this means that now I have a character which I'm reusing during gameplay, and it's exactly the same, but because this character is a prefab and can have overrides, I can actually add rigs which are unique to this timeline. So this rig is only going to be used in this timeline, and I don't need to worry in other places in the game where I might not need it and I don't want to pay the extra complexity and performance cost. So let's watch the animation first. You can see it to the right. So she goes for it. She's looking at the coin. She grabs the coin. The coin is parented to her hand, and she puts it in a pocket. So the point here is, as you can see, I've used an animation track where I have the idle animation clip, a walk, and then again the idle, you can't see the name, and then the same animation clip that I used before to take the object, but the improved version, right? The one that has the constraints on. And then I added an override track to be able to animate a few key parameters to make this whole animation unique for this timeline, and especially to control the two new rigs, the two new constraints, which I've added specifically for this timeline. So if I go into the animation panel by double-clicking, you will notice that she reaches for the coin. At this point here, I have keyframed the position of the target, as you would expect, because she has to reach for the coin. And in fact, if I enter record mode, I can actually move it and change the position, just like I was doing before with the animation clip. And then I just change the parent by switching the state of the multi-parent constraint, so that the coin is now parented to her hand. And then I also play a little bit with the head constraint. So you can see that the weight of the head constraint is a lot at the beginning, so she looks down to the coin, and then is turned down because otherwise she will just like bend her head in a natural position. And so it's brought down to 0, so that when she goes up, basically the original animation takes place, because the original animation already had her eyes pointing to the coin. So I don't need the constraint anymore. So this is just to show you the amount of freedom that you can have when you have these things correctly set up, and you can have a situation that you use for the gameplay, but then in a timeline, you use it in a more specific way. And just to show you how fast you can make changes to it, right? So let's say that the coin is actually here because we want to hide it a little bit better. It's too much like in the open. So we just need to basically change the coin word position, which is going to be where the coin is constrained to when the timeline is on. So you see now it's a bit hidden. And then we want to make sure that she moves towards the coin. So we just select the track and we change the offset. We rotate it a little bit so that she is as close to the coin as possible when she goes for it. So all the animation clips, which are exactly the same, are just going to be played, rotated a little bit to the right. And then finally, we just go again into the override track in the animation panel to the keyframe where we want to change the value of this right arm IK target position. We take it and we move it in the position we think it's ideal, like here, for example. Exit record mode, don't forget, go to timeline, and you enter preview again, and now we can see the whole animation being updated, and she reaches for the coin exactly like before, but in a different position. So we just reused the same animation clip with very minimal effort. The second feature that comes as part of the 2020.1 release of the animation rigging package, we call it animation authoring. When we talk about animation authoring, what we mean is the moment where the animator is creating new animation content within Unity. And previously I said that there's no reason to do this, right? Like that it makes sense to create your animation content outside of Unity. But there are moments when you want to do this. And for example, some main use cases. Imagine you want to keyframe some runtime rigs. So you have runtime rigs, you have rigs that will produce motion only at runtime, but you want to maybe fade them in or fade them out, or for instance, adjust the position of an IK target. And so you want to keyframe these rigs so that they can do their work at runtime in a better way. That's possible. Or maybe you want to sync one animation clip with another animation clip. And so you apply a runtime rig and you keyframe it to make sure that the two clips match and that they interact with each other. Imagine a character grabbing something from another character. Maybe the two animations have been made at different points in time. Maybe the original file is no longer accessible, or the person that made it is no longer working on the project. For instance, you could have bought this file from an asset store. And so with animation authoring, you can apply these fix-ups directly into Unity and make the two clips sync. Or add some other small fix-ups. For example, if you have an environment and the character is interacting with the environment, then maybe you want to retouch the animation just slightly to make it match that specific environment. And these changes might be scene specific. So as you use that animation in different environments, you need to change it every single time. And you can only do that inside Unity, because that's the only place where you will see that interaction happen. In 2020.1, runtime animations can be also baked in animation clips. So the runtime rigs that you use as part of the first feature that I mentioned before, when you do animation authoring, you can bake them into animation clips through something that we call bidirectional motion transfer. It's bidirectional because you can go two ways. You can go from the runtime constraint to the rig, right? So you have something which is supposed to work at runtime, but you bake it to the bones of the rig. Or you can go from the bones. So you already have keyframes on the skeleton of the character, and you bake that movement to the constraint. So basically, you are asking Unity to interpret that movement using the runtime constraints. And this is not always possible. Like, there are some runtime constraints which, it's impossible to recreate procedural motion out of keyframes. So these workflows, they work for the majority of the constraints, not for all of them. But when you have the possibility is really powerful. The ability to move motion back and forth between rigs, because you can do it more than once. You can potentially, have a clip that's already been authored outside, bring it in Unity, apply a constraint, bake those animation keys, and then remove the constraint, tweak those animation keys, and then maybe apply another constraint and keep refining. And this is super powerful. And all of these new keys, all of these new keyframes are stored into animation clips. So the workflow is that you just duplicate the animation clip and then you start tweaking it. And you get like a enhanced version, almost like a variant, right? Like the concept that we have in prefabs, where you add something on top. Now, for the purpose of animation authoring, let me show you another use case which can explain a little bit better why you would want to edit animation in Unity and how. I have this timeline where this little cute robot character pops out and takes a cup from behind its back and then makes some coffee and presents it to the player. Now, this animation, again, was coming from the original project, so I don't have the source files, but I want to tweak it just slightly because I added these particles and they don't really match the position of the hand of the robot, so the cup is slightly off center. And then the other thing is, because I changed the type of cup, the robot no longer holds the cup very well. So you can see that the cup doesn't fit inside its fingers. So I have a couple of things that I want to correct. And for that purpose, I took this original file, the original animation clip, and I made a copy. So you will see that I made a tweaked version, which is editable, of course. And let me show you how I edited things. If we go into prefab mode for the robot, you will notice that the robot is now in binding pose. And if it's not in binding pose, you can always go to here and restore bind pose. And in this situation, I've set up a couple of constraints. One, you can see it here, these orange circles, is a twist chain. The twist chain here is allow me to control the whole arm as a chain, and then I can bend this arm in any position I want so that I can tweak the position of the hand in front of the particles. And the second one is 3 different twist chains on the 3 fingers that the robot has, which are these 6 actually red rings. And I organize them under a different rig, so under a different layer, so that I can fade them in and out together, so that I can obtain a pose for the hand, and that pose I can fade it in and fade it out whenever I want. To show you the effect of that, we can just go into any animation, and if I preview, if I enter animation mode, you will notice that the hand is now not in the right position, but if I select this rig and I twist and I tweak it, I can see that the fingers are becoming active, and then from here it's just a matter of using rotation to pose them. And the other thing is this arm here. So if I take the constraint itself, I can then do this, and once the constraint is active, I can pose the whole arm by using just these 2 just these 2 controls. And as you can see, the whole arm rotates really, really nicely and creates like a nice bended curve. And so through these 2 controls, I created my updated animation, my tweaked animation. If I go to tweaked, you will notice that it takes the cup, and then at this point here, I'm fading in the arm control. You can see that the orange circles, they snap into position, and you will notice here at the top of the clip, I have here some weight keyframes. So you can see that the control goes from 0 to 1. I take control of the arm, And the position of the fingers is always on because, as you can see here, the whole 3 constraints are always on 1. So the fingers are perfectly holding the cup as I would expect. And then I take control of the arm. I position the arm right in front of the particles where I expect them to be. And then here towards the end, I fade it out again. So I basically blend into the original animation. So I'm only tweaking this part here at the center. And this is something we saw before with the girl, with the punk girl. But now there's the interesting part. For this character is not a runtime character. This is only going to live in the timeline. So I don't expect this animation to change ever. So why would I keep these controls as a runtime rigging? I can now bake them. I can now take this motion that the runtime rigging is creating at runtime and bake it into the animation clip. So to do that, what I'm going to do is I'm actually going to create a copy of this animation clip. I'm going to call it baked so that I can just preserve the work that I've done before. And if I go to the animator of this character and I drop the baked animation clip, which I just created, now I can preview the animation clip by going here. So I can preview the baked animation, which obviously is going to be the same because I just duplicated it. And now that's the important part. So now I select the constraints that I want to bake. So for example, I want to bake the, let's say that I want to bake the arm first or the hand first. I can go to this one and select transfer motion to skeleton. So because I go to the rig, this is going to transfer all of the motion for all the constraints that are under it. And I want to make sure also that I'm in the correct animation clip because this motion is going to be transferred, keyframed into this animation clip. So again, I select the rig, I click transfer motion to skeleton. And once I do that, you will see that some keyframes here have changed. And that's because Unity has transferred the motion and has keyframed these constraints to be on to 0. So basically it has zeroed out the, if I move the cursor, you will see that this is now on 0. So the whole work that the constraint was doing at runtime has been now baked into some keyframes here at the bottom. You hadn't seen it because I was scrolled up, but they're there. And then the other thing I want to do is I want to do exactly the same process for the right arm twist chain. So as I'm here and you see that the arm goes into effect, I will select this, right click, transfer motion to skeleton. And you see that the constraint is now off because you see that the orange rings are not snapping at any point because they're off. But the arm does exactly the same motion. And if I go to here, I think if I press Ctrl Z, yeah, you see the keys are being created and restored as I press Ctrl Z and Ctrl Shift Z. So I restored the same situation that I've shown you. So now the motion for both this constraint and this layer of constraints have been baked into this animation clip. And now what I can do is I can exit preview mode and I can totally like turn off these two objects and turn off even like any helper object that I had for the animation. And in the baked clip, everything will work just fine. So everything has been baked to keyframes. But at any point, I could also like re-enable them and keep working on this animation, which is the power of this system to be able to, make some tweaks, refine, bake, and maybe potentially, bake in the other direction. Because as you can see, when I right-click this, I have both options. I also have transfer motion to constraint. And that's why we call it bidirectional motion transfer. So now that I baked this thing, I can exit preview mode. I can exit the prefab. I can go to my timeline and swap the clip for the one that is baked. And now if I preview the timeline, I will see the animation as I would expect it with the proper finger position and hand position, but everything is keyframed. So I basically created some new animation data from within Unity based on top of some animation that was created outside of Unity. So as we come to the conclusion of this talk, let me just give you a quick wrap up. I hope you have understood through my demo how to create a more efficient animation pipeline. So something which helps you in producing more animation content at a lower cost. Obviously, animation rigging also gives you the unique ability to create runtime motion, which is something you couldn't do otherwise, or you will need some very complex scripting. And that helps elevate the liveliness of any character or even objects. Even objects need to be animated convincingly. And through this package, you should be able to do it in a much faster way. And also, I wanted to make one last point, which I hope I made with my demo. And it's the idea that animation rigging is a package that not only works for AAA pipelines, but also for smaller indie productions. Really, the advantage that this package gives you are so big that you want to use it even if you have a smaller game, and it improves your animation so much for a very small cost of work. If you're interested in bigger pipelines, though, my colleague, lead technical artist Dave Hunt, he's given a very interesting talk as part of GDC this year, which you can find on the GDC Vault for free, which is called Freeform Animation Rigging, Evolving the Animation Pipeline. So basically, he goes a little bit more into detail on the whole pipeline, starting from a DCC tool and starting actually from the rigging of the character, in a bit more of a complex use case and scenario, so bigger teams, and bigger projects. So the talk is really complementary to mine. It's really interesting. I really recommend to give it a watch. And if you want to download the project, you'll find the assets here. They're conveniently packed into a zip file, so you don't need to log in into GitHub or something. And you can download it even if you're not familiar with Git. And this is all from me. So I hope you really enjoyed this talk. I hope you understood the point of this package and what can bring to your project. And I hope to see you in the next talks.